The Oxford Dodo is the iconic representative of dodos. It's the most complete, it's the only one we can get DNA from. And so, as with all museum specimens, it's important to fully understand the history of the specimen. It's important biologically because it's one of the real icons of extinction. It was first discovered by the Dutch in 1598, yet it was extinct by 1662. And at the moment we've got incomplete documentary evidence. So the new forensic data really give us an insight into the early history of the specimen, how it was acquired, how it came into a museum collection in the first place. But the importance of the Oxford specimen is that it's the only one that retains any viable DNA. So it's the only one that we can do molecular analyses on to work out relationships and potentially in the future to reconstruct the genome of dodos.
Well, it was a real honour to be selected to carry out the scanning of such an iconic specimen. I mean, there are a number of international institutions that were vying to be the first to scan the dodo, and WMG at the University of Warwick was selected, and it was a real honour. So it's really important to remember that although this is a very famous museum specimen, it is the remains of a real creature. Original aim was to gain a unique insight into the biology of the dodo.
What we wanted to do was get a three-dimensional model of the skull, partly to work out the evolutionary relationships and partly to work out how dodos fed.
We were absolutely astounded to find that when we looked at the scans in close detail, that there were some mysterious lead pellets buried in the back of its head. And as luck would have it, we've used this technology to support and provide evidence for over 60 homicide trials. So we have a great deal of a forensic expertise, and we could then identify that dodo had actually been shot in the back of the head.
So we thought we knew the history of the specimen, and it was a really great surprise when the researchers at Warwick came back to us. The specimen that we thought we knew so well had lots of millimetre diameter lead pellets embedded within the skin, embedded within the bone, and it rapidly became apparent that this was actually lead shot from a gun.
So the scanners we use are operating very similar principles to hospital CT scanners, except the main difference, we provide many times more detail. We can see things that you would otherwise miss in a typical hospital scanner.
Using this machine, we take a number of images through 360 degrees, in fact a few thousand of them. At its core, this is exactly the same technology as what's used in medical X-ray CT. But because we're not limited by dose, because we're not scanning a real person, we're scanning inanimate objects, it means that we can get a much higher resolution. But because we've got a higher resolution, going down to the fraction of the size of a human hair, this means that we've got a much bigger data challenge. A single scan here would take somewhere to the order of 5 HD films, around 25 gigabytes. And if you imagine the size of the dodo, which was about this tall, it means that we had to do 10 individual scans. So then we're talking about hundreds of HD films here. We take these images and reconstruct them into a 3D volume, which then we're able to cut through sections of the skull non-destructively, looking at each individual slice, where every slice is this fraction of a hair thickness.
The next step would be to do some chemical analyses of the lead shots that we found in the skin and in the bone of the specimen. And using those chemical analyses, we may be able to trace which particular ore field the lead came from, and therefore what country it was mined in, and potentially what country the shot was made in, so that we could then determine who killed the dodo.
When you look into detail of the shot pattern and you see how the dodo died, it raises a lot of questions. Like, why was it shot? Where was it shot? And really we're hoping to use our expertise of working on a large number of real homicide trials to try and shed light into what actually really happened.
So it's an important specimen biologically, but it's as important culturally really, because the historical records of the dodo specimen are pretty scant actually. But we do know that in 1638 a retired MP called Hamon Lestrange recorded that you could pay to see a dodo and feed a dodo in London, and commented that it ate stones the size of nutmegs. From there, the next record we have of a dodo is in the collections of John Tradescant, where it was a taxidermy specimen, a stuffed specimen. And the natural assumption has been that that bird that Lestrange was paying a penny to see and feed was also the specimen that ended up in Tradescant's collection. And in 1860, when the museum had just opened, a mathematician called Charles Dodgson brought a little girl called Alice to see the dodo and other specimens, and they were particularly fond of looking at the dodo. Charles Dodgson was Lewis Carroll, the little girl was Alice, and a whole series of books rotated around Alice, of course. And from there, the dodo spreads culturally like wildfire and appears in everything from poetry through to Walt Disney films.